Imagine standing on an empty patch of dirt. Your job is to turn that nothing into a massive, functioning industrial factory. It is a monumental task that requires coordinating thousands of moving parts before you even start digging. Many projects happen in a brownfield site. On the right, you upgrade an existing factory, weaving new pipes through cramped spaces. On the left, a greenfield project. You start with a blank slate, with freedom to design, but most plan the infrastructure from scratch. Because you start with nothing, the success of the project is heavily weighted on the work done in the planning rooms. The deeper your understanding of the facility's needs during these early stages, the fewer costly obstacles you'll face once construction is underway. To manage that massive planning effort, project managers rely on visual timelines. Those blue bars sequence every task in order. Overlaid is this orange line, a mathematical graph tracking progress. Managers instantly see if the project is falling behind schedule. Building a factory requires an enormous upfront investment. Without these tracking tools, that capital can evaporate long before the plant is actually ready to start operating. So, how do we plan what goes into the plant? This diagram on the left is the broad map of the system. It defines the big picture, showing what the plant is supposed to do, like moving fluid from one tank to another. On the right, through the magnifying glass, we see the detailed construction guide. This takes those broad strokes and identifies every specific pipe, valve, and sensor needed to actually build and control the facility. Moving from that broad map to the detailed construction guide is the moment where a theoretical idea becomes physical engineering you can actually build. You can think of the finished plant like a living body. The gray steel beams and pipes act as the skeleton and veins, providing the physical structure and transporting materials throughout the facility. Those orange cables connecting to the large motor represent the electrical system. This is the muscle that provides the power needed to physically turn heavy pumps and drive machinery. Finally, the glowing blue lines represent the plant's automatic brain. This system uses sensors to feel what is happening in the environment and sends instructions to keep everything running smoothly. The steel pipes and electrical motors give the factory its strength, but the automatic control system provides the intelligence needed for the plant to operate safely on its own. To be intelligent, that brain has to feel what is happening. The top row here shows the core physical states: the temperature, the pressure inside pipelines, the rate of fluid flow, and the level of material inside the storage tanks. The bottom row tracks health and chemistry. Sensors monitor motor speed, whether a valve is open or closed, the chemical purity of the product, and even the tiny vibrations that tell us if a machine is starting to wear out. Gathering all this data is difficult. Out in the field, shown on the left, sensors are bolted to hot, vibrating pipes, enduring weather and dust just to take a single measurement. That measurement is then sent to the protected hub on the right. This is a clean, climate-controlled room where computers process the data and human operators monitor the entire system on screens. The plant's ability to react intelligently depends on this information surviving the journey from that harsh outdoor environment to the safety of the control room. Accurate data requires precise installation. First, flow disks must face the correct direction. Second, data cables must be segregated from high-voltage lines to prevent interference. Finally, rigorous loop testing validates the entire signal path from the field sensor to the digital control room screen. If you overlook these small details during construction, the sophisticated systems meant to manage the factory will be effectively blind. Engineering helps humans run the plant safely. Operator screens must filter noise to show only actionable alerts. Digital readings must perfectly match physical field dials for absolute accuracy. Finally, emergency stop buttons must be strategically placed for immediate access during a crisis. These 3 steps summarize what it takes to succeed. Project managers must anticipate the challenges operators will face, understand how the various systems overlap, and stick strictly to the construction guides. Building a greenfield plant is more than just assembling parts on an empty field. It is the process of designing a complex, integrated ecosystem that allows humans to